Hello, welcome to another video where we're working on Odin's interpreter I'm building for the Z machine, written in Odin, which was new to me, but I don't know, after a couple of months, I'm feeling a bit more in with it, I guess. So I guess uh, the last video I was doing restoring, but for saving, it actually has a feature that I don't have, kind of. So what I kind of want to look at is another tester. So if we look at our testers directory, I believe it's the czech, and this is the comprehensive Z machine emulation checker. Doesn't say who it was by, but it was probably by one of the people back in the day that was very involved with the Z machine and the specs and whatnot. And as you can see here, it kind of runs through and basically tests a lot of instructions. And I thought I would kind of go through this because mine goes up to about here and fails because call to S isn't implemented. So we can see that by call 1S, sorry. We can see that here, unimplemented opcode call 1S. So fairly easy to add this sort of thing. But what I was going to use this to do was actually to I can probably do something like that. What I want to do is feature. Well, I kind of want to consolidate the call instructions because we'll see shortly that um, I didn't actually do the search. If we search for one end, that should do it. And I think here we can probably yank to the dot and then paste that and then do that. Maybe I want to yank to the dot, then go to it, and then hey, I don't know. Yank to the dot. Do that. I just want to do that, but I'm trying to outvim myself. Um, so this one, it does actually need a stall. So we need dot call one. Where's my one? 1S is there. This chair feels slightly off kilter. Off center. It's a very heavy chair, so it's hard to kind of shift about. Um, cool. So here and yank, find that, and do that. No, we don't actually do anything here. But here we can yank, find that, and paste, and do that, and that. Doesn't need a Z string. Not many do. I wonder if I could do this a bit differently because only print and print ret actually do, like ever. So I wonder whether I can just have this as partial switch opcode or just say if opcode equals print or print ret, because otherwise you just have to list all the instructions multiple times. Like here there's a bunch of stores. I mean, the stores and branches, there are kind of some cases, but yeah, I wonder whether to. Um, well, I kind of like the Switch because it's. Well, we had. I think I'm bike shedding a little, but if we look for a cert, um, we can also look for get grep. And I want to search for hash cert. It's going to show me everything. Yeah, so I use it in header. And it's a little trick I saw from someone else. What do I want to do? I probably want to. I'm in Emacs. I'm in num ops. Yeah, so then we can do stuff like this. Um, I'll still do like a partial switch, but I'll also do a search. Gosh, how do we do the other search? Um, I'm definitely bike shedding, but oh well. And this way, you just want to be opcode dot num ops. Do something like that, and we can make this equal to some number. But I guess to do that, we need to do this. Actually, I'll just debug this and do what a cd and do something like that. Yeah. See what it wants. Actually, no, this we do need. Like shitting. Um, so this is just printing stuff out. Where do we do calls? This is probably suitable. That one, thanks. Where else do we have it? Num ops. And do we have call? And as you can kind of see here, just do unimplemented actually, and maybe put that there. Maybe just have it for everything. have something like that. Cool. Will it make something now? Right, looks like it works. And it reckons it is 71. So maybe search me that and 71. And just do stuff like this. And that way, next time you add in an instruction, it'll still take you to a point where you might need to look at um, especially this Z string one. What? Assert. Partial and do stuff like this, and make sure these all have partial, because these just really don't need everything. Cool. So now it's trying to do 1s. Right, so that was like a bit of a bike shed, so I might just do that bike shedding now. Oh, I didn't add that last commit. Get all these committed up. And what do I want to do? Use static sets to make opcodes start Odin there. That's a terrible message, but oh well, it's there now. And have I pushed since log shift? And what did this have? Yeah, so I might add a couple of other things like that. And do this. Cool. And get and get rebase minus I origin main sounds good. We'll stash what we have at the moment. just want to do that. And we'll pop that off. Cool, so that that was a weird way to resolve that. I shuffled things around, but yeah, we want log shift and the call 1x. Cool. So what do we look like now? I just want to restore stage source. Cool. So this should show everything. Except it's still got this. Had it, but that's alright. I'll make a stash again. Deja vu. Stash. Oh. What does this one have? Does this have? Ah, I was. Oh well. Cool. So anyway, might get out of there and back into this one and make sure everything works. Ah. Cool. Did lots of breaking things. Cool. Right. Back to where I was. So what call 1s is basically I've got a lot of call functions. This first call is the one I added to start with. And it does version 3 calls. I think it, yeah, does version 3 calls. Then version 5 kind of has a bunch more that you can do. You can do like 1N, 1S, 2N, 2NS, VN, and there's a VS that'll come up at some point. But what these all kind of do are the same thing, just depending on depending on whether you want to how many arguments you have, and depending on whether you want to save the variable or not. And one thing I hadn't quite understood was whether they all have this when address 0, which I think they probably do. Yeah, I think that would probably be the case. And yeah, I kind of do that here with the 1n, and also with the 2n and the 2s and the vn. Perfect. So now I kind of want to merge these together, because this 1n could just be part of this. It's well, what I'll do is actually make use of Windows. So 1n, what does it do? It reads the packed instruction, packed address. It unpacks it, like slightly different alignment. That's all right. It does this routine address. This is wrong, I think. Yeah, I think that needs to happen rather than just continuing. And we didn't have the VS yet. Yeah, cool. So if we go back to the 1n, so if it's 0, we do nothing. Here we write a thing, and in all the S calls, there will be that store that we need for address 0, which is why I just fixed that to S, I think it was. Otherwise, we read the routine, and if it's got a store, then we set it. And this should be safe to do for every instruction, because the has store will be false, and it will just set it to false, so that's all good. And when it's true, we'll set it to true. And if it's false, the store is just garbage. We never actually read it. And usually it should be 0, I believe, in the passing of the thing. And then here we yeah, 1n is actually a bad example, because all it does is call that, but it only has one operand, and we've already read it, and this starts from 1 and goes up to however many operands you do. So I guess if we look at 2n, we can see that the arg is just reading the operand, and then we put it in the variables array slice, I think it is. This could be slice or array, who knows. And we store that to that. And they all do this append thing, unless it's 0. So what I think we can do is actually do this, and not Z, 1N, and do that like a couple of times. For what we have, we also have 1S, and then we have, where am I at? One that, grab that, grab that, and do that. And we also have dot call. I might just close this. V, yeah, we just have VN. Here, what I can do is do that. Go here, go here, go here. That. Do something like that. And here, what we want to do, yeah, I think I want to, come on. Instruction.opcode. I think maybe I want to do a partial switch on this, and we're only going to look at a couple, like where, yeah, we're not going to look at the ends. And go back here and right, so if that is the case, then we're going to do that. And I think I also want to just open up opcodes and grab this assert and I don't know where it got that. Cool, and that get closed. Yeah, I think I like that better than the full-on switch, because that can be a bit. And this second half is it can just be the same. So I think that's just done, and it will do all the things that I need. And I think that just means I can get rid of all that, and deleting that much code is good. Easy. And so where do we get up to now? So we do a bunch of calling, and it's not printing any errors at the moment, so that's a good thing. I tested it with, well, I tested. The log shift was not doing the right thing for negative numbers, which was the case that it might happen. And it printed some errors. Like some errors from the check, the comprehensive Z machine checker. So here it just wants spheres too. Easy. Let's just add it. VS2 and just check that it gosh, up to 7 arguments. I guess it's checking it. I wonder if we actually support 7 arguments. I mean, it's got 7 there. Yeah, I'll add in this. BS2. Now we just need to do this. Cool. So in here, let's find the core family. Add in that buddy. Find that again. Add in that buddy. Here we've got one more. Go back there and go there. Go there. So we have one more opcode, and it's a call. It does not need a branch. So that's fine. Does it need a store? This VS2 does need a store, so we can edit. That's maybe slightly easier. So here we have one more. Want to find equal. Cool. And here we don't need a Z string. Easy. Right here, we are doing a store, so here we can just find the same thing. Find equal. And so because of that, we do need to add this. Yeah, cool. That's fine. So here, we do this. It does need a store. Here, I just didn't increment. Easy. Right, so memory out of bounds. We are having some issues. I also want to do a make. I need to do ROMs testers. Check the and I want to do TI just to see whether it yeah, so it only finds 3 arguments. So this is causing a bit of an issue. So these yeah, so only this MVS2. So gosh, I thought um, just adding another call would be easy. So I guess if that is the case, it is a var, so we can probably just chuck it here. So yeah, I guess if instruction dot opcode equals dot what was it called? VS2. I might do a partial switch on this bad boy, just because we will need the N2 at some point. Cool. So what do we want to do if this happens? We just want to do unlimited now, just to make sure we doing things good. So I want to search for a search. Why is my gutter showing that everything is added? Cool. Right. So I just want that and to add that there, and this probably needs that. So now it should probably go here, and what do we need to do? We need to have an extra byte of opcode bytes. So I think we just want to do this, not doing that. And maybe that. But I am unsure. Yeah, so it kind of makes it already. But because it is like capacity a word, we just search for cap. Yeah, so cap is just a built-in procedure. So if we have cap instruction dot operands, no, don't do that. Do come on. So if it is for we want to do one thing, otherwise we want to do that. And I think I want to do a check if cap instruction dot maybe actually just do this cap instruction dot operand. And we can just make sure that it hasn't been allocated yet. And here I want to extend to 8. So how do we extend? What are we doing? We're having a dynamic array. So we can dynamic array. Does this page have it? Dynamic array. Cool. I wonder if, well, like it has a capacity of so maybe do that, and it'll just keep growing. Um, maybe if we do something like that, and that should do the trick. And the first one would make it 5, and the first one would make it 1. In the 2 cases that would happen. So, how does this go? We get unreachable. Cool. Well, no, that's just memory out of bounds still. So we had uh, let's make, yeah. So it hasn't read the right bytes. It has not indeed. Hey, this is a trickier one. Is this the one that I want? Yeah, check. Well, actually, it says 145. So it should just be 1, 2, 3, 4, 5, 6, 7. But yeah, we're not getting that. We're yeah. This is odd. I guess if we go back here, wants to store it to some random address. How, gosh, how does it get done? Fundamentals, instruction encoding. Does this mention that call the, yeah, so the double variable? Um, Let's see what it is here. Oh, I see, I see, I see. Yeah. Gosh, what a case. Um, Alright, I think that is what we need. This is like a bit redundant, but I guess I can do something like that, but I think that probably is the best. So maybe like that. And there's no fall through in Odin. Well, there is if you put in fall through, which will fall through. But if you don't, then it's blocking itself. So it's kind of like an implied break. Cool. So I think this might do the trick. Yeah, cool. So now it's just going through to another call. And this should be fairly easy now. Cool. Let's go here. Paste that. Do that. Add it to. Search for this. So does this need a store? No. Easy. I like that. Clean up in code. It will complain now that we need to increment some of those asserts, the static asserts, but that's fine by me. Cool. Won't bother doing that. Find equal. Find equal. Weird. And here we actually do want to do call en every other op that we add to this, we will just need to bump this code, which makes me think we can probably get rid of that assert now because we've got the two instructions in the spec that we know have this double case, which in fact maybe I'll link this. Linking to specs is always good. I mean, it doesn't have the most intuitive name, but it allows people to no thanks about it. And I wonder if nah, that's just bike shedding. Again, um, I'm done a bit of bike shedding this episode, but that's all right. Cool. So here I'm doing some weird vimming. Do that and also do uh, that. And here we want to increment that. Don't want to add anything there. Increment this. Can we do that? No. Needs to be there. And does it need a store? No, it doesn't. It did not need a Z string. Cool. Just typoing. Cool. So that's getting to a point where we've got that. And this check arg count, oh gosh, that's actually kind of what I wanted to do way back at the start. So I think I will add all this up now before it gets kind of lost in the thing. Do something like this. Um, we will want to add something from it. Oh yeah, we've got that like consolidate call opcodes. That's probably all I'll say there. So now, what was the issue it came across? So this check our count code. If we have a look see down here. So this is branches if the argument number counting from 1 has been provided by the routine call to the current routine. So basically, you can call the same routine with a varying number of arguments, as we've seen from that call thing there. But what I kind of wanted to look at, not blob, Ketsu. What I kind of wanted to look at was how the stacks was done, because here we can see that in each frame we have the argument supplied, which somehow we need to know what the argument supplied was. And if we look in our Quetzal file, we yeah, when we read a chunk, so this will be the stacks. Right, so process stacks frame. Gosh, this code is like gross. So here I've just got to fix me, use args somehow, bitfield on which args are provided. So the reason why I didn't kind of uh, didn't can't do the save at the moment is the frames don't actually. We have a kind of number of variables, but that is actually um, just done as part of a make, and so it's always going to be a certain number of variables based on uh, what the routine says in the actual routine code. So it starts with the header byte saying how many variables it has, which we can see from this one, routines. So basically, it starts with just 1 byte number of local variables. So that won't really help us tell how what happens when you call. So what we need to do is actually have some way of storing how many things we call, how many, what our arguments that we call are, and whether we call with all of them or like none of them. So to do this, we need to look in our old execution and look at this big call thing here. So we actually get how many things that we how many arguments we have. We basically have a number of operands minus one. So we could actually just do something like routine dot what is it? We could probably just do count, and this can be len instruction dot operands minus one. And so this is going to complain because we don't actually have arg count in here yet. I can add an arg count in here, maybe just at the end. Arg count, and this can be a U16. I mean, really, it's a U8. Could do that for storage. Can only go up to 8. So may as well do that, which means that cool. We go back here. So this is going to be a U8, and let's find that with that. Cool. So that is basically our calling. So because we have done that, I think we should attach the fix me here. There's a few fix me's. So this args it is stored in Getzel argument supplied, so it's kind of just like a bit field. So we could potentially just store that argc as that when we do the call, and then we could just do something like frame dot arg count equal args. But I think what I want to do is actually gosh, what do I want to do? Because it starts from the right, so the first arg is there. This it kind of lets us like do a nice little loop. So frame should be 0 initialized. Cool feature. And we can do a for loop over what I think we can do stuff like this. So what are we doing in this? We're going to frame dot arg count. Potentially even if args. Actually, no, we want to have this in a block. So what we first want to do is have args. Do we have a that? I wonder. So we want that at the end. In fact, I wonder if we can just do that. And no, I think we can't. But if we want to go through all the bytes, but we actually want to go to only 7. Well, actually, we only want to go to 6. So that's going to be a range of 7, and there are 7 bits that we actually want to look at. The highest most bit is never set, pretty much. So what can we do here? So if we have args mod 2, and if that is equal to 1, where are my numbers there? So if it is equal to 1, we want to do a frame dot arg count. Yeah, arg count plus equal to 1. Could actually just do like a frame dot arg count equals not equals plus equals that stuff, because if it is equal to 1, then it will add 1 on, otherwise it will be 0, because there's only 0 and 1 in mod 2. And then we want to shift it to the right, which will take it down. And yeah, so this way we're just kind of testing each bit as it comes. And so I think that is kind of all we need from that. So now theoretically we should be able to restore save files with like an arg count, and be able to get the correct number when we go to what I actually need to do, which is check arg count. I might do something like this. Did I not add all of that last time? Cool. Um, pass kits. Oh, feel. I guess that can be that. Cool. That's using fugitive and fugitive. I keep on forgetting like you can actually do all the film stuff in there. Got it there. Right, so here I want to do a check account, and up here we probably want to maybe do it here. Cool, so now we just need to go through and do all the things. So this is what dumping. How does the old txt handle this? Probably just normal, right? Yeah, just normal. And by normal, I mean it's like just somewhere in here. This first one just does the prints the operands as whatever they are. If they're a variable, if they're a constant. But these other ones that I don't have to do too much for other things that kind of show off a bit more things, do things a bit different. That's just for printing. So here, what do we want to do? We want to go down to the call. Actually, we want to go down to rat, and we want to have this, but instead of jump, we want it to be check. I can't, and this we want to be check. I can't, and we just have it unimplemented. Implemented. Right, so does check count need a branch? I think it did. Branches if the given number is it doesn't show the branch there, but yeah, like it shows it there. You got a branch. It's kind of weird. So because of that, I think it was just before the jumps. Check count can go there. So does it need a store? So it does not need a store. Does it need does it need Z string? It does not. Does it need to be handled differently here? Eventually, this one will be able. This assert could go because once we have all the calls, which I think we do have all the call store ones, VS to VS, I don't think we have. Yeah, we don't have just VS. But once we get this, so maybe I'll add a recomment and remove after or VS is added. And then it's just one less thing to worry about. Cool. So check our account. We get to here. So what do we actually have to do? So branches if the given argument number has been provided by the routine call. So I guess there we can do like some general asserts. We don't want this to be, we can just call that A. We don't want it to be that. We want to get rid of that. And we probably want to has branch. Cool. So then the jump condition will be equal to current frame dot arg count. So if it has been provided, the arg count will be higher or equal to the number. So I think we can just do something like that, and there will be check arg count. So it doesn't like this. That's all right. We can get rid of that. I wonder if making count. Oh, it's set in stone now. Cool. So that didn't have any errors. We just had all the dots, and now we're getting to objects which we don't have any support for version 4 plus. But I think at this point, we'll add things up. So we can get rid of that. We can get rid of that. We can get rid of that, that. And what did we add just then? Check count. Cool. And so what do we look like at the moment? So now we can either continue down the check route, or what I was thinking of doing was for Zork 1, go back to Zork 1, and I have a input file. It's kind of a long one. I mean, this is a good test, I guess, having a longish thing. It looks like it's all working properly. I mean, this kind of uses some of the functionality of the engine. And yeah, here it will fail because we have not implemented save. So I think I'll just check my diff is empty. Cool, so save can go there, and if we look up restore, we can add a save there. Cool. I kind of want to just do a quick check because I have yeah, so let g last mega is equal I wonder if I can do this. And do something like that. And then maybe I can do this. Right, it didn't like something there. We've added save. But it has run the command that I wanted, which is kind of adding everything there. So what does save kind of show? Save, we can probably look at this and info from slash sort one, and I think it's a dat. And if we look up save, it's just a normal branch. Should be 0, I guess. Which I guess makes this, we can just put it all in here. Not that, that. Cool. This, what do we want? Um, it's not going as quick as it used to be. Might need to end the videos. Now, the save, in fact, the save and the restore, save. Um, so it, yeah, so we need to go back to opcodes. Yeah, cool. So here we need to actually pay close attention to whether it needs a branch. So it doesn't need a branch. Oh, we just doing something like that and doing something like that. And the arguments should get worked out automatically. Where do we get up to now? Find equal and do that. That's what I want. Cool. It has not. So just do that. We don't have that. Cool. So Quetzal save. Or Quetzal. So Quetzal save, and how do we need to do this? So true, do that and return true, I guess. Cool. So this should thought I'd change things there. Oh, I think it's yeah. Every time I open a file, it runs that file. This is looking good. So yeah, I think I'll leave it there because I don't really want to. My head's getting a bit sore, but well, not sore, just tired, not working probably. But yeah, I will come back to this. I'll either just do it myself or uh, do it in a video. But the gist is, it will basically be the opposite of this, but we'll need to um, we'll need to compress the data, compress the memory that we have against the well, compress. We need to like encode the memory that we have against the machine memory. Kind of like, well, we need to get the machine memory, but then we need to form a bunch of headers in the IFS format, which I think I had just a link to Wiki, but I did actually find this old link as well, which yeah, potentially kind of helps. But yeah, I'll basically have to build all these chunks, and then I will be able to save and restore files, and that will basically be like Zork is finished. But yeah, we'll see what happens. And like, yeah, it'll be pretty cool. Um, just finished. Cool. Add stub for save. Cool. So that's all there, and I'll come back to it. But yeah, I can just run this. So one dot dat, and like I can just play a game, which is pretty satisfying. I think I will just do a push so everyone else can enjoy it, and if they find their own thing. One feature I like really well about it is, well, like, so if I, for example, instead of running that and I run Zork, so you see here, like the status bar kind of shows everything. I'm in teammates, so if I get out of the full screen thing, the it kind of looks like it's kind of working, but if we go north, the text is kind of all weird, and it actually gets kind of impossible to play because like now you're kind of up here. Um, but one feature of mine is it just kind of works. I say that, but then it didn't. But it doesn't kind of get to a state where like it breaks the gameplay. It might just kind of look a bit funky when you kind of make it small. But yeah, that's how it is. And potentially, if we have a small one and make it big, it still kind of works. It just shows the wrong size, but it'll print everything here. But that whole screen layout will have some overhaul at some point. Just so, like the status line, it's only meant to get refreshed on every read, or like if you call a particular one, but it can also just stay there, I think. So if you kind of scroll this stuff out, like it will, if we have like a really long text, something like that. And like now you can't see it until you get back to it. Whereas I think if we did a similar experience in here, can we? No, can we go? Oh, yeah. This is one feature I like of Zork. I've got arrows here. Um, I think I wanted to start with a smaller screen. It doesn't remember. What a sidetrack. Can't see what I'm typing. That's a good place to look. What's that? Yeah, so here if we actually scroll past, it will ask for more, and it will always show it. But yeah, there's features of that I like and some that I don't. Um, but with that, um, I'll leave it there. Probably should have left it way back, but yeah. Thanks for watching. You can get the source code on GitHub. There's a link in the description. Um, if you find your old disk which has the ROM, you can get it. There are some people that just download it, but I would not advocate that. But yeah, thanks for watching. And if you enjoyed, let me know. And till next time, see ya.